Who will he become? What will be the story of his life? His is yet to be written, but mine is like a book that never ends. Yet I am a part of him, building him cell by cell, right here, right now. I am invisible to you, but if you look closer, you'll find me. See? You call me an atom, an element, a fundamental building block of life. You name me carbon. But would you believe me if I said that before I arrived here, I was here? I was caught by the wind, flung down and buried under the earth. I was breathed in by a falcon and expelled. I was burned in the belly of a machine. That's me, again, right there, coming out of the tailpipe. True story. This perfectly formed child is partly built of pollution, of waste. You think you know me, but do you?
The levels of carbon pollution in our atmosphere have increased dramatically.
Daily choice is to reduce their carbon footprint.
We'll abolish the carbon tax.
Global carbon emissions are tipped to hit a record high this
Start
year.
of yet another war over carbon.
People saying we have a carbon problem. What is your carbon footprint? What is your carbon tax? And I'm thinking, don't blame carbon. It's not carbon's fault.
Carbon is profoundly important in the universe. She is what makes us possible.
We are nature because we are made of carbon. So is everything else.
Every one of us lives in a carbon world. We have to learn to get along with carbon.
Nothing is more urgent to the survival of human civilization as we know it than understanding carbon and where she likes to hide.
I am the most talked about, but least understood element on Earth. If you are to survive me, you must understand me.
Carbon's one of those people where, when she was at high school, was just annoyingly good at everything. You know, she could play sport, she was in with the nerds because she was really smart, she was part of the orchestra, and was actually just a nice person to boot. Able to do everything, but watch out if you get on her bad side, because she's friends with everybody. If you get on her bad side, she can make life really difficult for you. If you want to see carbon, you don't have to go very far. You just look all around you and she's everywhere. On Earth, life and everything, it's all very complicated. If you want to look at the simpleness of carbon and the purity, you need to go up and look into space and look at the stars and the whole universe to really understand how she came to be. The Big Bang is the beginning of the universe. Everything that we can see around us was once compressed into a really, really small volume, and that expanded over time and eventually formed the universe that we know now. And in the middle of that, there were nuclear reactions happening. Some elements started to form. We originally had hydrogen, and then that became helium as hydrogen atoms bashed together and fused to form helium. But not much carbon was born in that time.
I am younger than the universe, born in the heart of a star.
Most of the carbon that makes up us and the Earth and all of the life around us comes from the inside of stars. Stars live by fusing elements in their core. So in mature stars, the core is really dense and gets really, really hot, like 100 million degrees. That's where carbon starts forming. To make carbon, it's actually really complicated. You've got to have an unlikely sort of reaction going on. You've got to have two heliums bashed together, which forms beryllium, but that's really unstable. It doesn't last for long. It basically disintegrates as soon as it is born. And in that fraction of a second, a millionth of a billionth of a second, when it's still hanging around, it needs to be hit by another helium. And when that happens, then you form carbon.
How strange to be created in that violent coincidence. That twist of cosmic fate.
So you can merge hydrogen atoms together to get helium. Next on the chart, you merge helium atoms together to make carbon. It's right up there. Happens early, it happens often. That not only happened early in the universe, it continues to happen to this day. So you don't think of carbon as when did it all arrive in the solar system? It is a continuously delivered product from the consequences of stars living out their lives and dying.
In the very early universe, carbon was just hiding inside stars, being born and hanging out there and just quietly staying where she was. It was only when those stars die, as they grow old, they get big and they lose much of their material out into the wider universe. That's when carbon emerged and said, hey, I'm here.
When the dust settles, what we find is that carbon is one of the most abundant elements in the universe, after hydrogen and helium. Where do those molecules go? And where do those atoms go? Well, they scatter into the galaxy, and they'll collect where there are gas clouds that will become the nursery of a next generation of stars. And each of those stars makes planets. And so they're made out of these birth ingredients of the cloud itself.
About a fifth of our bodies are made up of carbon, and that carbon comes directly from stars. So when I think about it and I think about where I come from, I can go back to my parents, but that isn't far enough. Going back further to the birth of life on Earth, that isn't far enough. We need to go all the way back to the stars at the very least, and where carbon gets formed in the centers of those stars. And then to think about it, there's a direct line from the birth of that carbon in stars to the birth of me here on Earth.
Peekaboo! Peekaboo! Peekaboo!
Your body, your mind, they are born of my collisions. You are made of stardust. So is almost everything else.
If I were to fall in love with an element, it would have to be carbon. I mean, carbon brings us beauty.
What does it smell like?
Carbon's fun.
Shake, 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 shake.
You know, carbon's reliable, it's strong, and it's also generous. all of our food that we eat and the clothes that we wear. And more than 90% of everything you see is carbon. It's in fabrics, it's in wood, it's in all the plastics, it's in our bodies. Every molecule, every cell in our body is just loaded with carbon. You can't escape it. It's part of our lives, and she is always with us.
So how did I come to be so entwined with every aspect of your lives? It's because I do something better than any other element. I socialize.
Carbon's the life of the party. She likes grabbing onto all sorts of different people, pulling them out of their sidelines and getting them on the dance floor, twirling them around, throwing them off and grabbing a new partner.
How can she be so versatile? How can she do all these different kinds of things, solids and liquids and gases, all at once, one element? And the secret has to do with a rule of nature. Nature has rules just like we have rules. And one of those strange rules is how atoms are put together.
I am made of even smaller things. Restless particles called electrons spin around my core.
There are certain combinations of electrons, exactly 2, exactly 10, or 18, or 36. And when you have those numbers of electrons, you've got an extremely stable atom. But carbon is 6. And as a result, carbon does every trick in the book to bond to other things to get more electrons.
I reach out to other elements to find partners, to make molecular marriages. And I'm always up for a dance.
Who is the life of the party? It's someone you just want to be near. It's somebody you want to attach to. And someone who you want to be your friend. So, yeah. You'll know when carbon walks into a party. Because that's when the partying begins.
She will react with all sorts of things and create a myriad of different compounds. Some of them look nothing like each other. So, I mean, in that sense, she's the ultimate fancy dress artist. Okay, so she can make diamond, which is, crystalline and bright and hard. And she can make graphite, which is a lubricant and black.
In bonding with others, I transform and build. And of course, everyone wants to bond with me.
Carbon's a pretty promiscuous atom. She likes to hook up with just about any other element in the periodic table. I mean, you got carbon here, and she loves to bond with hydrogen. That's a big one. You find a lot of carbon-hydrogen bonds. But she goes over to oxygen. She takes nitrogen. She does phosphorus, and she'll go down. She'll bond with iron and nickel and cobalt, zirconium. For gosh sakes, very few elements want to bond with zirconium.
She can also interact with herself, so she creates these kind of conga-like chains of carbon molecules. And those long chains suddenly open up huge, in fact, millions of types of different compound, different flavors of carbon, if you like. And there's no other atom in the universe that does this trick. Then she can make nucleic acids, which is the DNA of life. And suddenly the whole cornucopia of our lives, of life itself, is laid bare. This is the essence of you, it's the essence of me, it's the essence of life itself.
Without me, life would not exist. But how did that spark of life begin in your world? That's my doing. Let me tell you how. It began in such simple ways. But then life got complicated. I was destined to ride paths of ever-increasing complexity and beauty.
I'm a biologist, and I've been fascinated by beauty since I was little. And what I consider to be beautiful are all of the things that are made out of carbon. That is, everything in nature.
Oxygen is my perfect mate. Together we form carbon dioxide, CO2. This is the crucial bond through which I connect with all of life. And it starts here.
When you're looking at a tree, what you're actually looking at is sunlight, embodied sunlight, because plants have this ability to pull carbon right out of the air and use the energy from sunlight to make it into themselves. So in this way, trees are the air, thanks to photosynthesis. Photosynthesis is the most incredible process that nature ever invented.
Embraced by oxygen, I am lifted high. I roam the air, and if I am so lucky, I have the chance to enter the cycle of life.
The surface of a leaf is a veritable landscape of trapdoors for carbon. And this is where the entire ride of photosynthesis begins. Anytime that the sun is shining on the leaves of a plant, the photons or the energy packets from the sun are being captured. And just as those photons of light are captured, another thing starts to happen. And that is a water molecule, water that's been drawn in from the roots of the plant, is split apart into its oxygen, which diffuses out into the atmosphere, and its hydrogen. That's where the energy packet gets transferred. These hydrogen ions are like little packets of sunshine. At this point, carbon has been off to the side, waiting for these charged energy particles to be ready for her. She jumps onto a chemical Ferris wheel, if you will, in the leaf. And at this point, she's able to be fused to another carbon, eventually making a chain of 6 carbons. That is the simple sugar, or the glucose molecule. And it's these simple sugars that are the packed lunch of the natural world. This is the ultimate product of photosynthesis.
Oh, so much fun. Making millions of sugar molecules, fuel for all of life.
Once carbon has been transformed into her new relationship as a simple sugar, she can jump on any number of the highway systems that occur within the tree. The tree is essentially a moving factory of carbon going up and down and all around at all times.
You gotta love photosynthesis. Wow. Here we have this mind-blowing chemical sequence. And carbon is there the whole way, all right? You're not gonna do that without carbon. And what are we doing? We are taking sunlight and putting it through this mini chemical factory and outputting energy. That's extraordinary. Yet we want to think we're some pinnacle of evolution, when for us to survive, we have to kill other living things to eat it?
Yeah, I'm gonna take another bite.
Okay, ready?
Yeah, vegetarians, you're killing things too, all right? We're all killing to survive using the energies established by other life forms. The point is, the buck stops at the sun, because ultimately you are eating things for nourishment that had gotten their energy from the sun.
In a way, we're living sunlight because what we do is we eat the food that is ultimately the product of photosynthesis. And so in this way, yeah, we are embodied sunlight. It's what we are. The human body is kind of like an engine, if you want to think about it in that way. We need fuel in order to operate. And the fuel that we receive is carbon-based. And when we get these carbon sugars and we break them apart, the waste product that we give out is CO2. But you never know when her state is going to transform again, because if she floats a little too close to a large tree, well then bang! She might get sucked into one of those trap doors and the entire journey will begin again. So to understand the movements of this magical element, to understand how she shifts, how she becomes a solid, how she becomes back to a gas, how she forms me. All of this is what fascinates me as a scientist. We don't exist independently of nature. We are nature because we are made of carbon. So is everything else.
I make your world with my bonds, but these bonds can be broken. I build and I burn. The moment you lit your first fire, you learned to release the energy I store in wood. But you weren't content. You wanted more. Here I have been paralyzed for what seems an eternity. Hidden in black rocks you call coal. Until you wake me from my sleep. Now will you raise me up to your world?
So what is coal? Well, it's carbon, our friend carbon. She's in almost every atom of this, and it's ancient buried sunlight. You think about a tree, you cut down a tree and you burn it, and you're burning a few years worth of sunlight transformed to carbon-carbon bonds. That's wood. But coal, this is thousands or tens of thousands or maybe hundreds of thousands of years of wood, all squeezed down, all concentrated, all in one lump of almost pure carbon. That's concentrated energy.
What is this place? Deformed and ravaged. It was once so full of life.
About 400 million years ago, life learned to creep onto land, and within tens of millions of years, you had forests on Earth for the very first time. For the first time, Earth was green. And so what happens, these forests grow, and as they grow, the plants get taller, tree-like plants that were 30, 40, 50 feet tall, and they'd grow and then they'd die and they'd fall over. they did something strange. You know, if a tree falls over today in the woods, you come back 2 or 3 years later and the fungus has got it and it dissolves and it just goes back to the soil. The trees would fall and they'd just sit there. They wouldn't rot in the same way. And so a tree would fall, another tree would fall, and you get layer upon layer, and you get these accumulations of 50, 100, 200, 300 feet. This had never happened before. And so you're burying huge amounts of carbon in the ground. At first, that carbon is just dead trees. But as you keep burying them deeper, the pressure gets higher, the temperature gets higher, they get squeezed, they get baked. It becomes richer and richer in our element carbon. What an amazing way for carbon to behave.
In coal, I am the trashed remains from an ancient age. But when you discovered me, I became your treasure. After coal came oil and gas. You call my stores of buried sunlight fossil fuels. But now, it's not just fuel you seek. You've invented strange new molecules that never existed in nature.
She's this compressed magic of earlier life forms. They're absolutely an incredible resource for us. They are going to build our world, and they have the ingredients, this slumbering genius that is carbon in it.
Carbon, boy, she does so many interesting chemical things. I mean, I love carbon for this reason. And one of the things she does is make polymers. Nature does this all the time. Tree fibers and our tendons and our muscles, and we have all kinds of polymers in our body. You see them all around in nature. Spider webs, polymer. Hair, that's a polymer. But we've now learned to make synthetic polymers that have incredibly useful properties. We call them plastics.
She's broken up into small molecules, and then these need to be joined together into long chains. Now, the molecules are little units, if you like. Let's say we'll call them a mer. And if you put them all together into long chains, you get many of them, poly of them. And so it goes polymer, and that's where the word polymer comes from. So it's the creation of long chains of the same molecule joined together.
And in this strange, unbreakable form, I become even more useful to you.
And out she comes, now no longer sort of black and crusty out of the earth. She's these pristine, almost pearl-like nodules, and these flow like sand. And into the injection molding machine she goes, and then for a few seconds held in a close embrace, and then the mold is released and out she comes in a new incarnation. And so polymers and plastics, these are two sides of the same coin.
3, 2, 1.
And there's polyethylene and polystyrene and polyurethane and all these different polys. They're just little molecules that are linked end to end.
Almost got it.
It's light, it's incredibly strong. These are all plastics. It's almost a miracle.
You push me and pull me into extraordinary forms. But you don't seem to value these new wonders that you've created.
Well, we don't treasure it enough to hold on to it, and we let plastic just litter the planet. And because it lasts so long, because it is so valuable a material, it will last in geological time. When people look back at this period in the geological strata, they will see layers of what? They'll see layers of plastic laid down in the ocean. We're laying them down now. And that, I think, is really disturbing and worrying, and I think it's about us. It's about how we treat this most valuable of resource.
Like magicians, you bend the world to your will in the blink of an evolutionary eye.
Humans use just immense amounts of carbon and other materials to make our stuff. The total amount of materials that humans have manufactured, that includes plastics, and includes steel, and includes asphalt, includes all kinds of materials, it's greater than the total mass of all the biosphere, the trees and the elephants and the ants and the coral reefs, all that stuff. Humans have made more than all of that biomass put together.
The last 2 or 3 centuries, we've developed this relationship with carbon that has benefited us humans in many, many powerful ways. It's been very exciting. It's given us a sense of superpower. It's made humans feel like gods. We now have the feeling that we're managing a planet. But what we're beginning to learn is that we're in a lot less control of things than we thought. And the power itself is dangerous.
You think you control me, but you forget. I have changed your world in the past. I will do it again. Today, I'm being awakened like never before, raised high within molecules of carbon dioxide traveling to the ends of the earth. Here, I ride what you call the cleanest air in the world, like the breath of the planet exhaled, along with the rhythm of the Earth's resting heart rate. This is where you take my pulse. You measure me.
How do scientists measure carbon dioxide in the atmosphere? They take a glass sphere, they evacuate all the air from it, so it's a vacuum inside, and then you take it to a remote part of the atmosphere and you open it up and all the air rushes inside, and then you take that glass sphere back to your lab and you hook it up to a machine that can distinguish between all of the different gases in that sample. That's how scientists have been regularly monitoring the contents of the atmosphere over time. And that's how we know that carbon dioxide is building up. Carbon dioxide levels back in the 1800s were around 270, 280 parts per million. Today, they're already over 420 parts per million. We have not seen carbon dioxide levels in the atmosphere at this level for over 15 million years. So some people would say, well, so why does that matter? Carbon dioxide has been higher before, hasn't it? It has, but there was no humans around.
Remember when I helped form your world? Creating a warm, wet greenhouse. Perfect conditions for the origins of life. I wrapped you in a warming blanket.
Well, how does a blanket keep you warm? So a regular blanket traps your body heat. That's exactly the way the greenhouse effect works too. The sun's energy shines down and most of it goes right through this natural blanket like a window. It hits the earth and the earth heats up. But the earth is a lot lower temperature than the sun, and so the earth gives off infrared or heat energy, as opposed to the sun, which gives off visible energy. The Earth gives off this heat energy, and it turns out that heat-trapping gases like carbon dioxide, water vapor, methane, and others, they are absolutely perfect at absorbing that heat energy. So in a way, carbon dioxide gets very excited when she sees that heat energy coming, and she soaks it in and vibrates and rotates and then gives it off again. But she gives it off not just upward, but in every direction. So it keeps a lot of that heat energy just bouncing around in the lower atmosphere, and that's how this incredible, natural, invisible blanket protects life on Earth.
Since the last ice age, I have given you almost 12,000 years of stability, a precious time in which you have flourished. Now I am rising again into the air, but this time it's different.
We built civilization after the Ice Age on a stability of climate, with the expectation that this amount of carbon dioxide in the atmosphere will produce this kind of cycling of the seasons and this level of warmth, and we put cities on coastlines. We have farmlands, specifically selected places that thrive in the climate out of which civilization was forged. The problem comes about if you start doing things that interfere with that equilibrium. What? We have fossil fuel waiting to just get pulled out of the ground that's been there for 100 million years? And it's got our name written all over it? Oh my gosh, let's go yank it out of the ground and burn it. You will create a level of warmth on this earth that civilization has never seen. And that's a problem. You're cashing a check you didn't write. You're withdrawing from a bank account you didn't create. Now we say that's carbon, I'm saying it's carbon dioxide, please.
We study volcanoes, we study the sun, we study all the reasons why climate has changed in the past, and we know that today, every single one of those has an alibi. It really is our use of carbon. It's not carbon herself. She didn't choose to do this. It's the way we are using carbon that is causing this problem.
I know I am mostly invisible to you, but our paths cross every second in millions of ways.
Do you need a mattress, maybe?
Here's another one. You can give this one to the baby so the baby can sleep in there with it.
I am unleashed by many tiny touches. At the flick of a switch, the turn of a dial. And as these pieces of me rise, I warm the planet. Just a little bit more.
We've never had this type of change happening so fast on this planet.
And we can see that today with melting permafrost. It shows or indicates we're approaching a tipping point. And when we hit that tipping point, the Earth can flip into a state we call hothouse Earth. It's going to lead to tens of meters of sea level rise, coastal flooding, enormous dry areas, droughts, and so on. And when rain comes, it'll be much more intense and violent. Storms will be much more violent. Many parts of the earth will become uninhabitable for humans. Carbon has gone from being a benevolent force, a protector of the Earth system in a stable state. But now as she's being released and increasing in the atmosphere, she's becoming a destroyer of ecosystems, damaging human health, and so on, in a very short period of time.
Now my fires are raging, destroying all the life that I once helped build, with a fury that I cannot control.
This is part of this new normal. This is actually a scientist's worst nightmare. The very thing that we've been trying to talk to people about is actually unfolding right now. And so I think we need to come to terms with these irreversible losses. And I think that's something that I started to come to terms with, realising that we are part of this generation that are witnessing the destruction of the earth.
I can take everything that you love, every place that makes your spirit soar.
And there's no way of really describing it because it's a profound sense of grief and loss and something that's infinitely precious that's slipping through your fingers, and that's all there is, and it's going to go. I think it's one of those things that when you feel that if you call for help, that someone will respond. And I think there are moments where I feel like abandoned in that space, and it feels like the bleakest landscape you can imagine. I guess the main thing is if you think about your life and your kids and your own culture and existence on the planet and think that that might not be a given.
Don't you see all you stand to lose? If I have nowhere left to hide. But there are a few places left on Earth where I can still find refuge, somewhere to rest. These places have been my sanctuary for thousands of years. But for how much longer?
Carbon loves to be in plants, and the biggest plants on Earth are trees, and so she loves, sequestering herself in these huge cathedrals, really, these huge cathedrals of carbon, with all of her friends and cousins and relatives. If you imagine yourself as Miss Carbon, you would be being photosynthesized. You'd be drawing down CO2 from the atmosphere and fixed through photosynthesis in these beautiful crowns, and then moved down into the roots and stored in these very stable compounds in the soil. And this cycle happens, every day. It's just this huge drawdown of CO2. Fly over that beautiful canopy, and suddenly they've just cut a clear cut. And every time we cut them down, carbon is released. She ends up back in the atmosphere. What we found is that immediately after harvesting, that about 60% of the carbon in that forest is gone just like that. So what are we doing? I mean, these old growth forests that store some of the biggest carbon pools in the world. And those are the ones that we're cutting. The carbon cycle shows that we're all irretrievably connected. We're all in this together. That we are intimately part of the cycle too. We're made of carbon. What we do affects that carbon cycle, and that carbon cycle is affecting the livability of our planet.
I find myself bereft, in the air, looking for places to hide.
The number one thing we need to do with carbon is leave her in the ground. If that doesn't happen, we can't solve this issue in any other way. She must be left in the ground, and we must do that as fast as we possibly can. But we already have too much carbon in the atmosphere, so we have to learn how to draw down some of that carbon.
Humans have emitted so much CO2 that nature can no longer keep up. Trees simply don't grow fast enough in order to deal with the amount of CO2 that we emit. So we need to find new technologies that can short-circuit nature, that can help capture CO2 faster and balance this carbon balance out. Carbon is really difficult to find in the air because she is at such a low concentration. If you were to try to grasp some air in your hand, only 0.04% is carbon. That's a tremendously small amount. It's trying to find a needle in a haystack. She is that needle in the haystack in the air. So the energy cost with which to search and find and extract and capture her is just so high. The question isn't whether or not it can be done, it's being done today. The facility that we're in right now captures 3,000 tons of CO2 per year. Now, when we think about that, that's actually a very small amount of CO2 compared to the 40 billion tons of CO2 that we emit as a species every year.
Direct air capture.
What needs to happen is these direct air capture facilities need to scale up and they need to scale out. They need to not only increase in size, but they also need to increase in number. My vision for the future is one where 100% of our energy consumption comes from renewable sources, sources that do not emit carbon. This means that we no longer have to disturb her. We no longer have to dig her up as a fossil fuel, burn her, emit carbon dioxide into the air. Rather, we can just leave her where she is.
We don't have to project 1 minute into our future to see that the climate crisis is already here.
Government organisations to be carbon neutral by 2020.
Make a decision to live a carbon neutral
Put
life.
our nation on the road to net zero emissions no later than 2050.
To me, 2050 isn't just a number. It's not just some year in the future. It's my life. It's what I'm going to experience. It's what I'm going to live through. I will be the one who has to experience and survive the consequences of the actions that we as a society make today. And I also think that's why you see my generation fighting so hard to change the way that society operates. So it's an entire generation of people who recognize and feel viscerally that their future is at stake and want to fight for it. And most importantly, what you can do is vote for the leaders and the policies that will take action now. We really need to put people into office who can make impact now and who recognize and understand that this is a problem that we need to face.
I can feel a change. I see it in your faces. So, builder or destroyer? Which do you want me to be?
Every one of us lives in a carbon world. We are carbon life. Carbon pervades every minute of our lives from the time we're born and we're wrapped in a soft blanket to the time we die in a silk-lined coffin. Carbon literally surrounds us. It is us. It is part of us. We have to learn to get along with carbon. And she's very happy to get along with us if we treat her right.
In some ways, carbon's just a visitor because her lifespan is so long that we're just a blink of the eye. She can see us form, she'll be part of our lives, but then go on. Carbon's our ancestor. She gave birth to us, but she's also going to outlive us. She's much more durable than any sort of particular combination of her atoms with other atoms. She's much more durable than humans, much more durable than our Earth, much more durable than our sun. She will go on, even as all of those things die and go into new forms. The carbon that does leave Earth can go out and form other stars after gravity does its work and pulls lots of different particles together somewhere else in our galaxy. And around those stars, new planets might form. And so once a carbon particle is born, once it's released into the universe, she's going to live basically forever.
Maybe when you go out and look up at the night sky and just imagine planets with life on it, given all that carbon has going for it, that life is probably carbon-based. And so rather than think to yourself, gee, I'm not unique, no, say to yourself, gee, I'm a participant in a great unfolding story in the universe, a nuclear story, a chemical story, a biological story, where I have kinship across the cosmos. Because wherever I find life, it's going to have some carbon chemistry just the way I do. Why not use that fact not to feel small, but instead to feel large and feel cosmically connected as never before?
My journey will go on, with or without you. You are the writer of your story now.
Woven inside you, before and behind you, I make, I take, I build, I die.
Now you are becoming, awakening. It's time.
Wade into the river, the current will guide you into a violet sky, a field of stars where we were born.
Good job. Did it. It's a boy. It's a boy. You got a brother.
I'll be there in the end, and the start of a story. Life begins again. Breathe in and breathe me out.
You see me now, in your vast, complex world, and in this little life. And I am here right now in the nerve cells of your mind, enabling you to have this very thought, in this very moment. I've been holding you, helping you see. I've been here all along.
I draw the circle